You know, most AI tools are pretty good at explaining what happened and why. But the questions we really have, the human questions, are often a bit different. We want to know, can I actually trust this decision? And what can I do about it? Well, today, we're going to dive into two really powerful ideas from Explainable AI, Anchors and Counterfactuals, that are built to answer exactly those questions.
At the end of the day, it all boils down to these two things, doesn't it? First, how can I be sure this decision is solid, that it's stable? And second, if I don't like the outcome, what power do I have to change it? These are fundamental questions about trust and about agency. And the tools designed to give us those answers are anchors and counterfactuals. So here's how we're going to break it down. First, we'll get to grips with anchors and how they offer a bit of certainty in a sea of data. Then we'll look at counterfactuals and the power they give us to find a different path. After that, we absolutely have to talk about the ethics involved before finally seeing how these two ideas come together to create a more trustworthy and, frankly, more hopeful kind of AI.
Right. Let's start with this idea of stability. Imagine for a moment you're a loan officer, and you're using an AI model to help you out. You need to know if its recommendation is robust, or if it's just teetering on a knife's edge, ready to change with the slightest nudge. This is exactly where an anchor comes in. So what is an anchor? Well, think of it as a guarantee. It's a beautifully simple if-then rule that pinpoints the absolute core conditions that are locking a prediction in place. In this loan example, the rule is crystal clear. If an applicant's income is over £55,000, their credit score is above 700, and they have no history of defaults, then the model is going to say approve. Simple as that. As long as those conditions are met, the decision is anchored. In this 96% figure, that's what we call the anchor's precision. It means that as long as our three conditions are met, we can be 96% sure the model will return an approved decision for any similar case. Other things, like the applicant's age or where they live, can change all they like, but that decision holds firm. And that, for a loan officer, provides real confidence in the AI's stability. This is the core idea, really. You've got this vast sea of data with countless variables swirling around. The anchor is the small set of conditions that keeps the ship, the prediction, steady. It carves out a pocket of certainty from what would otherwise be chaos, stabilizing the decision against all that minor variation. So how on earth do we find these rules? Well, it's not magic, it's a very methodical search. An algorithm starts by generating lots of simple candidate rules, maybe just based on one feature. For each one, it measures its precision, so how often it's correct. But it also has to measure its coverage, how many people or situations it actually applies to. The real goal is to find that perfect sweet spot between the two. Because look, a good anchor isn't just about being right, it's about being usefully right. A rule that's 100% precise, but only applies to one single person in the entire dataset, well, that's not very helpful, is it? As you can see here, the ideal anchor has incredibly high precision. That's what gives us trust, but it also has reasonable coverage, which is what makes it broadly useful and meaningful in the real world. Okay, so anchors provide certainty. That's one side of the story. But what about the opposite scenario? What happens when you get a decision you don't want? And what you need to know is what you can do about it. This brings us to the other side of the coin, counterfactuals.
Let's meet Anna. Her application for a loan has just been rejected by the AI model. Now, her question isn't a technical one about feature importance or model architecture. It's a deeply human, deeply urgent one. What can I do to change this? She's asking for a path forward. She's asking for hope.
And a counterfactual explanation gives her exactly that. It doesn't just deliver a no, it reveals the road not taken. It shows her the smallest changes that would have flipped the decision to an approval. For instance, it might say if your income had been £52,000 instead of £40,000, you'd be approved. Or, alternatively, if you could get your debt ratio down to 32%, you'd also be approved. Suddenly, she has clear, actionable choices.
So, at its heart, finding a counterfactual is an optimization problem. The algorithm is searching for the closest possible version of Anna's profile, the one with the absolute minimum changes where the model's prediction flips to the outcome she wants. It's all about finding the nearest possible alternative reality where things could have gone differently. Now, this is incredibly powerful stuff, but it also comes with an immense amount of responsibility. Not all mathematically possible counterfactuals are good ones. In fact, some can be downright unhelpful or even deeply harmful. And this brings us to the ethics of how we build these systems.
For a counterfactual to be useful and ethical, it has to meet 4 key criteria. First, it's got to be valid. It actually has to work. Second, it should be minimal. Changing 1 or 2 things is a plan, but changing 20 is just overwhelming. Third, it must be plausible. Suggesting someone increase their income by £1 million is just not helpful. And finally, and this one is absolutely crucial, it must be actionable.
And this really gets to the core ethical principle here, actionability. It means the system itself has to be designed with guardrails. The search for a counterfactual can't just be a blind mathematical exercise. It must be constrained, ethically, to only search for changes that a person can actually make.
Think about it. A system that suggests a person would be approved if only they were a different age or from a different country, well, that isn't providing an explanation, is it? It's causing harm by pointing to a path that's impossible to walk. Genuinely actionable advice focuses only on what is within a person's power to change.
Right, so let's bring these 2 powerful ideas, anchors and counterfactuals, back together. Because they aren't really separate tools, they're 2 halves of a whole, and together they provide a complete, truly human-centered explanation.
This table just lays out the beautiful symmetry between them, doesn't it? An anchor answers the question, why is this decision stable? And it provides certainty and trust, mainly for the person making the decision. A counterfactual, on the other hand, answers, what can I do to change it? And it provides agency and hope for the person affected by that decision. One explains stability, the other explains the possibility of change. And that right there is the synthesis. When you use them in tandem, they create an ethically robust and complete form of explainability. The anchor validates the decision by showing its solid foundations, while the counterfactual ensures that decision doesn't become a dead end by always offering a clear path to recourse.
It really does boil down to this simple, powerful equation. By giving us certainty about the present and a sense of agency over our future, this combination fosters both trust in the system and hope for the individual. It's a fundamentally more humane way of interacting with automated decisions. Which leaves us with a final and pretty crucial question. As AI makes more and more high-stakes decisions that affect our lives, our finances, our health, our careers, we have to demand more than just a simple verdict. So, how do we build AI that doesn't just act like a black box judge, but instead becomes a partner in a dialogue? An AI that's ready to explain not just why, but also what's next?